Alright, example 6. Keeping going here. Right, find the formula for the mass that remains after t years. So the important things that I pick out here is 0, 100, our initial condition. And after 1590 years, we have half of that left. Alright, so find the formula for the mass, blah, blah, blah. So y equals, we know that this is an exponential decay here. C equals C times e to the kt. We know 100 is our initial condition. And we're trying to figure out what is the constant of proportionality. Alright, so I'm solving this here. I get now ln of 1/2 equals 1590k. 1 over 1590 ln of 1/2 equals k, and there are numerous ways that I can rewrite this. For right now, I'm not going to, though. So then our last thing is y equals 100 e to the, I'll just write it like this. It's not too bad. There we go. That is our formula. Okay, find the mass after 1,000 years. So for part B, we're looking for y of 1,000. Okay, which I think if you plug that in, I think it's 64.665 milligrams, right? That's what we started with. And for your whisk, I'd like you to do part C. You're just trying to find out when your function equals 30. All right, so you can do that part. Great. Example 7. Suppose the amount of oil pumped from one of the canyon wells in Whittier, California, decreases at a continuous rate of 10% per year. Since it's decreasing at this continuous rate, we know that it's an exponential decay here. When will the well's output fall to 1/5 of its present level? So we don't have any kind of initial condition or anything like that. But let's just assume it's 100%, because then 1/5 of that, that'll be easy to find. All right, so if we put our initial amount as 100, and it's decreasing at a rate of 10% per year, so we're only taking 0.9 or 90% of what's left over from year to year. All right, and now 1/5 of that would be, this would be 20 over 10, that's 1/5. There, that's where that 1/5 came in. 0.9 t. Solving that, we get ln of 1/5 equals ln of 0.9 times t, and ln of 1/5 over ln of 0.9 equals my t. All right. And if you want a decimal, great. I don't, because I don't have my calculator handy with me. So there you go. That's it. Number 8, suppose that a population of fruit flies grows in proportion to the number of fruit flies. Okay, so it's growing in proportion here. Keyword. So, after the second day, there are 100 flies. And, the 4th day, there were 300. So we know it's growing at an exponential rate. Okay, so now I'm just plugging in those points. 2 equals 1. Alright, I'm making a few mistakes here. Slow down. 2 equals CE. Better yet, I'm going to do it with my bigger one first. So 300 equals C times E to the 4K. And my other one, 100, equals C times E to the 2K. Now, this is a system of equation. We could do substitution. We could try some kind of elimination, okay? But I'm going to choose to divide them. Okay, 300 divided by 100. That's 3. C e to the 4K divided by C e to the 2K gives me e to the 2K. Alright, so we get ln of 3 equals ln of 2K. Not ln of 2K, it would just be 2K. Yeah, alright, 2k, there we go. Solving for that, ln of 3 divided by 2 equals k. Alright, so now, how many flies were there in the original population? So I'm going to plug that back in to one of my equations. 2 times 1/2 ln of 3. So 100 equals c e to the, that would just be ln of 3. E to the ln of 3 is just 3. Alright, solving, you get 100 over 3. Or 33 1/3 fruit flies. You know, because when you start with a group of fruit flies, you probably have some leftover wings or legs or something like that. That's where that extra third comes from. Sure, why not? Alright, one more problem. Look, AP 2008, number 5. So this is towards the end of the AP exam. Alright, you have this differential equation where x can't be 0. That's why there aren't any dots here. So don't draw anything on the graph if they tell you x cannot be 0. Now sketch a slope field. You can just pick random points, or to save time, let's look at the top. We have y minus 1. So anytime y is 1, we're going to get a slope of 0. Alright, now maybe you want to pick some other points. So when x is 1 and y is 0, we're going to have a negative 1 slope. When y is 2 and x is 1, we'll have a positive 1 slope. Okay, when x is 2 and y is 0, we get negative 1/4, so that's really not that steep, okay? And then up here, x is 2, so we get 4 on the bottom, y is 2, we get 1 on the top, 1/4. So positive, not very steep. So then we have negative 1 for x, which just gives us 1 in the denominator, 0 for y. So we have a negative 1 slope. That's at close to 45-degree angle. All right, and then negative 1 gives us a 1 in the bottom. So we have a positive 1 slope there. All right, so we have that is part A. Now for part B, find the particular solution to the equation. This, you need to separate your variables, okay? So we get 1 over y minus 1 dy equals 1 over x squared dx. We are going to integrate both sides. Again, you might even get a point just for writing that as separate variables, even if you can't do anything else. ln of y minus 1 absolute value. So if you need to, think about this as x to the negative 2. When we take the derivative, we add 1 to the power and divide by the new power. Okay? So I'm just going to write that as negative 1 over x. And don't forget your plus c. Alright, so then we are going to rewrite this. That's e to the negative 1 over x. Plus c. But remember, I also can write it as e to the c. Alright, so then I can get rid of my absolute value, and I get c e to the negative 1 over x. And then lastly, just add 1 to the other side. So we get c e to the negative 1 over x plus 1. Alright, now use my initial condition. Alright, so we have f of 2 equals 0, so we could say at f of 2 equal to 0. 0 equals c e to the negative 1/2 plus 1. Okay, just solving this here. So we get negative 1 over e to the negative 1/2. So it's the same as negative e to the 1/2 or negative square root of e, whatever form you'd like. Alright, so now find the particular solution. We're almost there. Just need to write it out. So y equals negative e to the 1/2 times e to the negative 1 over x plus 1. Now, since those e's are being multiplied, you can combine the exponents if you'd like, but I'm not going to mess with it. It's an open-ended problem. I don't want to have to worry about that. In the last part, c, we're trying to take the limit as x approaches infinity of f of x. So the only x value I'm plugging it into is here. Now for this, what is this limit that would be 0, right? So e to the 0 power is 1. So we have negative e to the 1/2 plus 1. Or if you really want to get fancy, you could write it like this. So a lot of people didn't get this problem on the AP exam, but I think that you guys could, especially now that you've seen it. Okay, continue working on your worksheet. Talk to you in class.